Finding the length of a guide wire. The height of a radio tower is 500 feet and the ground on one side of the tower slopes upward at an angle of 10 degrees. So that's like 10 degrees of elevation. Part A is how long should a guide wire be if it is to connect to the top of the tower and secure at a point on the sloped side 100 feet from the base of the tower. So this, they got a picture for you. So this picture I draw one myself. So from the bottom of the tower and then to this point, the distance is 100 feet. And then we have an elevation of 10 degree. So let's say we have a right angle. So this is a 90 degree. And then they have an elevation of 10 degree. And then we have a 90 minus 10, so this must be 80 degree, right? Because my 90 minus 10 is equals to 80. So that means A is 80 degree. All right, so A is 80 degree. That's the only angle we know, and we know that the height is 500 feet, and then the base of the triangle is 100 feet, and they're looking for a guide wire. So this will be this piece, right? So that is the guide wire. So this is big A, then this must be a small a. So that is for part A. Part A, the purpose is we are trying to look for the length of the guide wire. So that one will be using law of cosine. So we have A square equals to B square plus C square minus 2BC times cosine of A. So we know B, we know C. The only thing we don't know is we don't know small a. So A is equals to, this is B, right? So B is equals to 100 square. And then C is the height of the tower, minus 2 times 100 times 500, and then cosine of A, which is 80 degree. All right, and then you evaluate this using a calculator. So that is 100 degree, and then plus 500, not 100 degree, 100 square plus 500 square minus 2 times 100 times 500, and then times cosine 80 degree. That is equals to 242,635.182233. And then take the square root, square, right? So A is equals to the square root of that. So that is 242,635 and then 182233. And then what is that equal to? So this one is second, the square key, the square root of the previous answer, right? So you press second and then you press the negative sign. So that is around 492.58 feet. 492.58 feet. So that is the length of the guide wire. So that answers part A. This is part A. And then part B is how long should a second guide wire to be if it is to connect to the middle of the tower, so middle of the tower, and be secure at a position of 100 feet away from the base on the flat side. So let's change colors for that. So 100 feet away. So we have a point right here and then connect it to the middle of the tower. So this one, we need to connect that to the middle of the tower. So somewhere like right here. All right. And then this is 90 degree. They are asking for the length. So this, we call that a Y. So this one is a right triangle. Then we can use the right triangle trigonometry, right? Do we really need the right triangle trigonometry? I don't think so. So they have a right triangle like that. So this is a Y. This is 100. This is a right triangle. Since that is the middle of 500, then that will be 250. Then this will be using the what? The Pythagorean theorem. That applies to right triangle only. So that is the square of a base plus the square of the height equals to the square of the hypotenuse. So that is y squared equals to 725, 0, 0, and then you take the square root of that. So that is around 269.26 feet. So that answers the second question. That is the length of this guide wire. All right, so that will be all in this part. I will see you all in the next lesson.